Alrighty, guys, let's get going on this quadrilaterals practice problem, massive packet. We're going to start off naming the most specific name for each figure. So I think this first one's kind of obvious here because we have four sides of equal length, makes it a rhombus. Four angles that are all the same makes it a rectangle. Anything that's both a rectangle and a rhombus is automatically a square. Bada bing, bada boom, nothing much to it. On question number 2, like I was just saying before, if all four sides are exactly the same length, we have an automatic rhombus. And not all the angles are the same, so not a square. But we have the word rhombus there. Nice and easy. Questions numbers 3 and 4, actually both exactly the same. I'm not sure why my machine there put them in this order and why I didn't check to fix it, but the idea here is this one is just going to be a quadrilateral. And so is number 4. You can't see it good. And that's going to be your name for any not specific shape. Continuing on to questions numbers 5 and 6. For these ones here, number 5, anytime you have two sides the same next to each other and the other two sides the same next to each other, we call this a kite. You could also kind of see that it's a kite if you were to draw a line kind of going straight down the center here and another line on this guy right there. Now it kind of looks like a kite from maybe like a television show or something. And maybe a real life kite if you ever go out and fly one. Question number 6 here. This one is going to be a trapezoid because you have exactly one pair of parallel sides, but it's an isosceles trapezoid because these two are the same length. So we're going to call that an isosceles trapezoid. Boom, boom, boom. And then question number 7. We had already talked about this once before. We had the same exact shape. It's going to be a rhombus. All the sides are the same length. And then number 8, I think this one's nice and obvious. We have 4 right angles. If you got 4 right angles, you got a rectangle. Question number... Oh, I forgot to circle some of these. It's okay. Question number 9. This one, you have 2 pairs of parallel sides, no side markings whatsoever. That's going to be called a parallelogram. Number 10, you're specifically told that the two sides are of different lengths, the two pairs of sides. So yet again, another rectangle. And our very last one down there at the bottom is a trapezoid. Already done with the first page and the first 11. Let's move on to that next page. Question number 12. This is another one where you have two sides next door to each other the same length, another two sides next door to each other that's the same length. It's yet again a kite. And now we move into the actual math problems. So for these actual math problems, I'm going to need a calculator for at least a couple of them. So I'm going to pause and grab one for myself. Right, it's just a moment in time for you, but a little bit of time for me. I got my calculator ready to go for when I need it. But here we go, find the measure indicated. So for the first couple of these, all you have to know is that all quadrilaterals have a total angle sum of 360 degrees, and then we're going to use that to figure out what x is, then we can use that to figure out the measure of the specific angle. So here we go, we're going to go ahead and do 65 plus 106 plus 18x minus 2 plus 19x plus 6 is going to be equal to 360 degrees. So we're just doing this one, this one, this one, this one, all four added up to 360. After that, it's going to be just like we've been doing all year. We're going to keep all the x's on the left-hand side, everything without an x on the right-hand side, and changing the signs where appropriate. So minus 65, minus 106, adding 2, subtracting 6. So we subtracted that one, added that one, subtracted that one. 18 and 19 together is going to be 37. And we have the first one that I'm going to be way too lazy. I'm going to be using my calculator for sure. All I'm doing is typing it in exactly as it appears. Minus 65, minus 106, plus 2 minus 6. Get 185. And then we're going to divide both sides by 37. So x is 185 over 37, which is, in fact, equal to exactly 5. Last but not least, you got to take this answer of 5 and plug it back in up here for the measure of angle x. So the measure of angle x is equal to 18 times 5 minus 2, and that's going to be 88 degrees. Moving on to question 14 is a lot easier because there's no x to solve for. So it's kind of just like all of them right away add up to 360. So 83 plus 97 plus 110 plus that question mark, I'm going to call it the letter x, plus x equals 360. Sorry if you couldn't see that for a moment. So x is going to be equal to 360 minus all the other ones. In some sense, you could have skipped that very first step. You don't really need to write that down. You could have just started by subtracting. And yet again, my laziness coming in. We're going to go ahead and subtract minus 83, minus 97, minus 110, and that's going to give you 70. Continuing on, we're going to do question number 15. Same exact concept, remembering that this guy right here is a 90-degree angle. Don't forget that. So we'll have 90 plus 74 plus negative 5 plus 22x plus 17x plus 6 is equal to 360. Same exact idea as that previous one. 22x plus 17x equal to 360. Minus 90, minus 74, plus 5, minus 6, 39x equals, here's my laziness again. You can see it's always on subtraction. My mental math skills went away with COVID, and I wish they would come back. 195, dividing on both sides. That's going to be answer of 5 there. And then here it wants us to find the measure of angle T. So our measure of angle T is going to be equal to negative 5 plus 22 times 5. And that's going to give you 105. Boom, boom, boom. Not too shabby. Let's go ahead and finish this one off. Like I was saying up on number 14, the question directly above it, you can simply start off right away by doing 360 minus all of the other ones. And that is all you've got to do. Using my calculator off to the side of the screen, I didn't even move it this time. So if you aren't even listening to it, then you wouldn't even know, or maybe you just think I'm like doing nothing for a minute. Get 110. Bada bing, bada boom. Moving on to the next page. Question number 17 here. So on question number 17, same exact concept, nothing special whatsoever, but I will show something that I've seen other teachers do. So this is going to be a little bit different than the way I showed in class, and maybe it makes more sense to you to do it this way. So you start off by saying that the measure of angle G is going to be 360 minus the other ones. And you figure out that that measure of angle G is going to be equal to, so 360 minus 95 minus 115 minus 65, and you get 85. But the measure of angle G, you're told here, is 11x minus 3. So you kind of just do it like this, where you have a slightly less, I don't know, it's just a different way of approaching the question. So you have 11x is 88, divide both sides by 11, you get 8, and the question only wants you to solve for x, you don't even need to do anything else. Continuing on, question number 18. Same exact idea on this one. I'm going to do it the way I've been doing it in class, though. So 42x plus 2 plus that 75 plus that 94 plus that 105 equals 360. And then we got a 42x is equal to 360 minus all of the other ones because they are all addition. 42x equals, and I am using my calculator yet again here. Hopefully you guys are doing all good. I'm looking forward to Thanksgiving break. It is so close, right around the corner. But first, we got to finish up the 74 question packet. We're on to question number 19. Lucky for us on question 19. Oh, could you even see the rest of that problem earlier? I don't know. Well, now you can. Hopefully that's long enough. Okay. Number 19 here. This one's going to be nice and easy because it tells you it's a parallelogram, and parallelograms have a rule that these two angles here opposite each other are always equal for a parallelogram. So in other words, the answer to this one's 126. Nice. Question number 20. This one, oops, that was weird. I hope the video's okay. Kind of freaked out on me on my screen. It says DK is 10.6, so that's going to be this one. And one of the rules for your parallelograms is that the diagonals bisect each other, so that means that this guy right here is also 10.6. So 10.6 plus 10.6 gives us that whole length DF all the way across, and that's going to be 21.2. Moving on to question number 21. So question number 21 there, we're told that BZ here is the x plus 4 and ZD there is 2x minus 6, but it's a parallelogram, so those two things are equal to each other. Doing our little switcheroo action we've been doing all year long. And finally, it tells you to plug it into BZ, and you're going to get 10 plus 4, and that's going to give you 14. And this one, I really don't know what happened on this one. This one, it tells you that this length is 6, and then it asks you what this length is when it's the same length, so it's just 6. Yeah, there's like crazy amounts of work on one, and then it's like nothing work on the next one, and you know, I'm gonna blame these people over here. Definitely not my fault, even though I hit print without looking at it. Yeah, no, definitely not Mr. Richard's fault. Nope, not today. All right, here we go, 23. So on question 23, this one's tough to see, but this one does refer to that angle S up there. And one of our main concepts for parallelograms is next door neighbor angles. Adjacent angles is what they're called, and the correct terminology is going to be 180 degrees. So 3x plus 15 plus 39 plus negative 6 plus 9x, those angles that are up at the top up there, going to add up to 180 degrees. So 3x plus 9x is going to be equal to 180 minus that 15 minus that 39, adding the 6. Oh, no idea what that is. 180 minus 15 minus 39, add 6. Get 132. And divide both sides by 12. That's going to give you 11. And the measure of angle QST, negative 6 plus 9 times 11, 93 degrees. Oof. Question number 24. So you're told, again, these are all parallelograms. Opposite sides of parallelograms are equal to each other. So that's what we're going to do. Negative 2. Oh, pause and take a drink. All right, there we go. All right, we got negative 2 plus 10x equal to 8x plus 2, because those two sides are equal to each other. Going to go ahead and move all those x's over to that left-hand side, all the not x's to the right-hand side, 2x equal to 4x equal to 2, finding that EF is going to be 8 times 2 plus 2 is going to give you 18. There we go. Question number 25. Here we go on to question number 25. So yet again, we're told that these two things are equal to each other because it's a parallelogram. However, it does tell you that FD, which is the entire length from side to side here, is going to be x plus 32. So you have 2x plus 16 here. In other words, there you have 2 of these 2x plus 16s is going to be equal to x plus 32. And it will end up looking like a trick problem. A lot of students just don't like seeing 0 show up in the question, but that's okay, because you're going to get 4x minus x is equal to negative 32 plus 32. You get 3x is equal to 0. In other words, x is equal to 0. And finally, it tells you to find what this guy is. Plugging in 0 plus 32, and you just get 32. FU is 2x plus 16. So 2 times 0 plus 16, and that's going to give you a 16. All right, there we go. There's our final answer. I'm going to go to answer 27 right away because it's like already here, and this is just 20. And yet again, I don't know why these are so easy sometimes randomly. But that's okay. Life goes on. Here we go. Question number 26. So question number 26, that's going up here into this corner. So exactly the same as question number 23, just different numbers. So 28x minus 2 plus 27 plus 11x minus 1 equals 180 degrees. And then we're going to do something a little bit faster. So remember, you can do like things like 28 plus 11. That's going to give you 39. And then you can do that subtraction on your own. So like 180 looks like you're adding 3, so 183, and then subtracting 27. So that will be 154. Yeah. Divide both sides by 4, or by 39, and you'll get 4. And last but not least, the measure of angle S. So the measure of angle S is equal to 28 times 4 minus 2, and that's going to be 110 degrees. All right, 28. This one's a freebie because the next door neighbors add to 180, so the question mark plus that 80 degrees is 180 degrees, or in other words, that question mark is 100. Moving on to question number 29. So question number 29 here. What the heck happened on there? Got some kind of smudge. Whatever. All right, 2x minus 10 is going to be equal 2x. And that's going to be a nice easy one. 2x minus x is equal to positive 10, or x is equal to 10, and then you plug in wx, and that's going to be 2 times 10 minus 10, which is still 10. Bro. Lots of 10s. This one, number 30, another freebie. This guy is just 12. Nothing to it. Nothing special here. Some of these problems are easy, some of them are hard. Let's move on to question number 31. Solving for x. Each one of these is a parallelogram. More parallelograms in action here. These two, again, add to 180 degrees. So we're going to have 80 plus 8x plus 4 is equal to 180. 8x copied down, 180 subtracting both of these, and that's going to give you a 96. Dividing both sides by 8 there, and that's going to give you 12. Moving the ball right along here. I'll show more work on this one. I've showed less work in the last couple. We'll show extra on this one. So 17x plus 1 plus that 60 equals 180 degrees. So 17x equals 180 minus 1 minus 60. 17x is going to be equal to 119, or in other words, x is 119 over 17, which is going to be 7. Moving up to question number 33. So on question number 33, again, parallelograms have opposite sides of exactly equal length. So a little bit less work again. Adding 1 to both sides gives us 16. Dividing both sides by 2 gives us 8. That's all we needed. Same exact idea on 34, and honestly, I'm the type of person that says, if you could just notice that if you have 21 here and it's equal to 4x plus 1, so you subtracted 1 right away and just divide by 4, and you get the 5, you really didn't need the equation here, but, you know, we'll show the work for the video. We're almost halfway through. 3 more questions to halfway through. Question 35, here we go. Question number 35. So yet again, they add up to 180. Showing extra work again. 21x plus 25x equal to 180 minus 6 plus 10. 46x is going to be equal to, I can do math, 184, and then 46 goes into 184 4 times. So x is going to be equal to 4, but you got to figure out the measurement of angle U. And you might have actually been able to figure out if that was a 90-degree angle. It looks like a square as it is, but probably better just to show the work for it. There you go. There's that smudge again. The smudge is moved. You can't see the smudge yet, but the smudge is moving. So it like moves across the page. Maybe it like continuously moves like every page. We're going to find out. This is the most exciting thing in the video. Where is the smudge next? All right, moving up to question letter D here. In an isosceles trapezoid, not question D, question 36. In an isosceles trapezoid, the base angles are the same. So these are isosceles here, meaning that this guy over here is also 103, and this guy over here is also the question mark. Regardless, they're going to be equal to each other, and the opposite sides here are going to be adding up to 180. So we have that 103 plus, I'll call it x, equals 180. In other words, x is going to be 180 minus 103, or x is equal to, what was that, 77? Yeah, 77. 77. Boom, 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 boom. We're moving on to more trapezoid questions. In the trapezoid questions, you're always going to have these like two sides. These really should have been marked as parallel, but I guess it's like quote unquote obvious that these ones aren't parallel and these ones are, and you're told they're trapezoids. Whatever. The angles that are not on the same parallel line always add up to 180. Well, they're on the same line over here, but the idea is they're same side interior angles. 21x minus 11 plus 13x minus 13 is equal to 180 degrees. And 21 plus 13 is going to be 34. 180, adding 11, adding 13 is going to be 204. 204 divided by 34 is, in fact, 6. And it wants us to find the measure of angle G, which is 13 times 6 minus 13, or in other words, 13 times 5, which is 65. Huge. Moving on, 38, measure of angle F. So on this one, these are, if you notice, again, we have the parallel sides idea, but like on this one, they were on different parallel side, like different parallel lines, but these are on the same parallel line on an isosceles trapezoid. So these are going to be equal to each other instead. And on this one, I'm going to go ahead and get 10x minus 11x. I'm going to show the extra work on this one. 10 minus 18. 10 minus 11 is negative 1. 10 minus 18 is negative 8. Or in other words, x is equal to 8. Finding the measure of angle F is going to be 10 times 8 minus 10, or 70. We did it. Moving on to question 39. Has the smudge moved? Oh, there is no smudge. All right, well, all my fun has been zapped away. Isosceles trapezoid, in an isosceles trapezoid, the base angles are going to be the same again. So we have 7x plus 12 is equal to 8x. I'm going to subtract 7x on both sides. Makes more sense in this problem because we already have that constant there. And oh my gosh, 12 is equal to x by itself. 8 minus 7 is 1. We don't have to do anything else. The measure of angle x now is going to be 7 times 12 plus 12, or it's going to be 84. And you're asked to figure out what the measure of angle W is, and the measure of angle W is going to be 180 minus that 84. That's going to give you 96 degrees. That's a degree symbol. I apologize for my bad handwriting. Number 40 there. So on number 40, same exact concept as number 39, really you're just subtracting from 180. So we have 180 minus 105, and that's going to give us 75 degrees. Same exact idea on question 41. Question number 41, we got 180 minus 95, and that's going to give us 85 degrees. And 42, yet again, I don't know what's happening on this packet. Some of these questions are way too easy. But I guess you got to get freebies every now and then in the math class, especially in a 74 question packet. We are past the halfway mark. I missed it. Question 37 was the halfway mark. Here we go. Question 43. Question 43, find the diagonal indicated for each trapezoid. These are now fresher in my mind, so I probably know the answers in advance, but that's okay. We have x plus, okay, the diagonal. Idea is in isosceles trapezoid, the diagonals are also identical to each other, and that's what you're told. HF is x plus 7, GE, 3x minus 15. These are going to be equal to each other. One good idea, just I guess to talk about, is the fact that we don't have to move x's to the left. We can move them to the right. And it makes sense on this question because if I move that x over, I have positive numbers. And if I move that 15 over, I get positive numbers. And this way, I have all positive numbers everywhere. Kind of makes things a little bit prettier. It's just not a requirement to do, and it's not how I've been doing it in class. Sometimes it's good to switch it up, though. There's no degree symbol on this one, so it's just 18. 44 is exactly the same concept. No difference whatsoever. 5x minus 1 equals 7x minus 9. And then just like the last one, I'm going to move the x's to this side so that I have all positive numbers. I think that is the right way to do it. The better way to do it. It's just not something that you have to do. And yeah, there you go, 19. Moving on to question 45 and 46, we had a couple of freebies here yet again. So idea is this is a kite. In a kite, a couple of different things happen. Not only are these automatically right angles, that's one of them, but also these two parts here are going to be equal to each other. So those two parts being equal to each other means that our answer here, mx, is going to be that whole length all the way across, which is 48 divided by 2. Nice and easy. Question number 46. This one, yet again, I don't even know why it's here. They're marked as the same, so of course they're the same. Why is this even a problem in the program? I don't know, fam. Moving on to 47. This one looks nice and easy, and it is nice and easy. 3x plus 4 is equal to 2x plus 10. Subtract that 2x on both sides. Subtract that negative 4 on both sides. X is therefore equal to 6, and SR is the same length as QT, which is the same length. It's 2 times 6 plus 10, which is 22. Beautiful. Question number 48. This is probably one of the harder questions on the packet to really get right. And the idea is that on a kite, the angles that are opposites and in between, so two things, opposite and in between, the sides that are different lengths are equal to each other. Or in other words, this one is also going to be a 32x minus 2. And that's going to mean that all four of those add up to 360 degrees. So 32x plus 4 plus 32x minus 2 plus 32x minus 2 plus 72 is equal to 360. Adding all three of these up, 32, 32, 32, all add together to give you 96x. You're going to be 360 minus 4, add 2, add 2. Notice that does nothing. If you add 4, subtract 2, that's like nothing at all. And then subtracting 72 is going to give us 288. And 96 multiplied by 3 is 288. So measure of angle G is going to be 32 times 3 minus 2. That's going to give you 94 degrees. Nice. Question 49 is a lot faster. The reason why question 49 is a heck of a lot faster is the fact that here's a little x there, here's a little x there, and those two little guys have to be the same because it's an isosceles triangle. So we have x plus 80 equals 180, or 2x is equal to 100, or x is equal to 50. Please note, you could have just subtracted 80 from 180 and then divided by 2. That's kind of how we taught it back in the isosceles trapezoid unit. But maybe you didn't remember that. Doesn't matter. Here we go, 37 degrees. That one's an easy one right away because kites bisect exactly the same on both sides there. Easy peasy. Moving on to question 51. This one is marked to be the same, and it's also an 8. I wonder if it's like a conspiracy with the number 8 here. 52, yet again, a super duper difficult problem. So it goes from a freebie number 51 to a difficult number 52. 3-step process on this one because we're trying to figure out, hey, what the heck is this guy? I'll call it y over here. A little y there for measure of angle D. We know that all three of those have to add the 360. The problem is we have two different variables, so we wouldn't be able to figure out which one is which. But we are able to know that these two are equal to each other. So we can do 11x minus 4 is equal to 14 plus 9x, Or in other words, 11x minus 9x is equal to 14 plus 4. 2x equal 18. X is equal to 9. And now we're going to go ahead and plug in that 9 into either equation. Doesn't matter which one. I am arbitrarily choosing angle A there, 11 times 9 minus 4. 99 minus 4 is 95. And finally, the measure of angle D is equal to 360 minus 72 minus 95 minus another 95 equals, I don't need a calculator. This is going to be 98. I remember because I did it earlier today. I was in class. Cool. Question 53. So question 53, we're going to have x's on both sides here. It's one of the rules we just talked about in a kite, is they're identical when they're opposite each other, and in between the sides that are different lengths, they're not the same on the other side. That's why we couldn't just do something fast like on 52 saying it's just 72. Can't do that. No way. Not allowed. All right. So instead, now we have x plus 89 plus 91 equals 360, or 2x is equal to 180, or x is equal to 90 degrees. We're done. And so we get to question 54. And on question 54, this is a rhombus. Rhombi have the rule that the opposite sides are the same. So that's going to be 11x plus 2. And this is an isosceles trapezoid. Or in other words, this guy right here is the same as this guy right here. So this one is a 2x plus 14. And now we can just go ahead and set up the equation, all adding to 180 because it's a nice little triangle. 2x and 2x and 11x is 15x. 180 minus 14 minus 14 minus 2 is 150. Divide both sides by 15. You're going to get 10. After that, your last step is to figure out the measure of angle R, which is going to be 11 times 10 plus 2, which is in fact 112 degrees. Super duper nice. We are now on to the parts that I actually haven't taught in class yet, the area questions. So let's see how much I remember off the top of my head. Hopefully I don't have to pause the video to have to learn something, but you never know. You never know if I've forgotten something. Here we go. Find the area of each one. So I will care about units for the honors geometry class. I don't think the on-level geometry class is going to care about units too much, but I think it's still a good habit to get into. Remember that area has square units. That's going to be one of our key concepts there, doing those square unit problems. So you have 4.7 times, oh yeah, this is going to be area of a parallelogram is going to be the base times the height perpendicular to the base. So it's going to be 4.7 times 4. So 4.7 times 4 is going to be 18.8, and we're going to have centimeters squared. Beautiful. Question 56. This one is a rhombus. Rhombi and kites both have exactly the same rule. That rule is very straightforward. It is diagonal times diagonal, divide by 2 for the area. The concept is it's like all these are like triangles that are cut in half, and because they're all triangles that are cut in half, it's just going to be the diagonal multiplied by diagonal, all divided by 2, and that's kind of what you're doing there. So in this case, the diagonal is this whole up and down here. So you're going to have 6.1 multiplied by 11.1, all divided by 2. No idea what that is. I can do some math in my head, but definitely not this. That's going to be 33 points. And I think, it doesn't say on here, we are supposed to round to 1 decimal place on most of these questions. So that's what I'm going to do. I'm going to round it to 33.9 centimeters squared. If you put 0.855, that is acceptable. You can do that too. All right, question number 57. So on question number 57 there, oof, I can't speak. Rectangle, area of a rectangle, going to be nice and easy. Length times width, base times height. I don't really know what to say on this one, other than the fact that our area here is going to be 5 times 6.3. And what's that going to be? 31.5. See, I can do some math in my head. Don't forget your centimeters squared on this one. Next one's going to be feet squared for our triangle. Triangles have that area formula. If you did not know, our area is going to be 1/2 times the base times the height that is perpendicular to the base. Height that is perpendicular to base is 2.8. The base is 3. The 5 is useless. 1/2 times 3 times that 2.8. Our area is therefore going to be, what is that going to be, 4.2? Yeah, 4.2 feet squared. Nice. All right, question 59. I already wrote that formula. This is another one of those diagonal situations. So our diagonal situation, look at this though. Look at me being a little bit rude here, right out of nowhere. So here's my rudeness. If you notice, this is in inches and this is in feet. You can choose to answer in feet or inches. I don't really care which one you do. However, you have a choice. You either say, hey, this right here is going to be the same as 5.7 times 12 because there are 12 inches in a foot. So this is going to be the same thing as 68.4 inches. Or you go over here and you say that, oh, by this is because you can't see it on screen, but I did times 12 multiply by 12. But if you're doing this one, I would end up dividing by 12 instead. So you multiply by 12 to get from feet to inches, getting a bigger unit. There's a bunch of different unit conversion stuff we could talk about, but I am not going to right now. Instead, we get 12 inches here, or 12 feet, sorry. So there's two possible answers to this question. The two possible answers to this particular problem, we're going to have either going to be a 12 times 5.7 and then divide by 2, and that's going to be your answer in feet squared, square feet. So 34.2 feet squared. Or the other option could be simply taking the bigger number, the 68.4. That's going to be the inches version times 144, all divided by 2. Holy moly, that's going to be a big number. 68.4 times 144 divided by 2. Turns out that's 4924.8 inches squared. So here are our two correct answers. And if you wanted to show that these are the same thing, because you divide by 12 to go from inches to feet, you divide by 12 twice to get from inches squared to feet squared. So if I simply took that 4924.8 and I divided by 12 and then divided by 12 again, and I just divided by 12 twice, you'll notice I get that 34.2, same exact answer as the feet. I'm done talking because number 60 is so simple. The area of a square is going to be the side length squared. That's where the word squared comes from. 10 times 10, 10 squared, 100 miles squared. 100 square miles is huge. Holy moly. If you're having trouble figuring that, there are 10 blocks in a mile, so like 10 different street names, right? 10 different street names. Sometimes like the big huge names on like highways will be every mile, but if you're on like smaller streets, 10 blocks. So that's going to be 100 blocks by 100 blocks. That's massive. Massive. Really big. All right. Here we go. 61. We're getting to the end here. We have another triangle. 1/2 times the base times the height that is perpendicular to the base. The other number is useless. 1/2 times 11.6 times 8.2. So 11.6 times 8.2 divided by 2, and we end up getting 47.56 inches squared. Keep the ball moving. We have a trapezoid. We haven't had a trapezoid yet. Our trapezoid area formula is going to be, we have base 1 plus base 2 divided by 2 multiplied by the height that is perpendicular to the base. There are other versions of it. Some teachers write it like 1/2 base 1 plus base 2, or they do like base 1 plus base 2 times the height times a half, or half the height. There's a lot of different ways to talk about it. I don't really care which way you want to talk about it. There's a couple different ways to go about it. But this is how I'm doing it. So our area here is going to be 3.9 plus 8.3, all divided by 2, times this 8.2, and that's it. Yeah. So we have our area equals, and we're going to put this into our calculator. Don't forget to use that fraction button. If you forget to use that fraction button, it can make your life a little bit more difficult, but you would just have to make sure you use parentheses correctly. If you're doing it that way, you get 50.02 centimeters squared. Bada bing, bada boom. Moving on to 63. So on 63, you have another kite. Same exact idea. Diagonal, diagonal, divide by 2. So 7 times 5, divide by 2. 35 divided by 2 is what, 17 and a half? Yeah. 17.5 yards squared. And on this one, it looks like we have kilometers instead. So we're going to have some kilometer action going on. We have 3 times 9 divided by 2. 27 divided by 2 is 13 and a half kilometers squared. Not quite as big as our 100 miles squared, but still pretty large. We got another trapezoid. Our area is going to be base 1 plus base 2 divided by 2 times the height. That is perpendicular. The 4.8 and the 5.1 are useless information. Do not try to use them. Oops, I don't need that. I need fraction button, not answer to fraction. 4.4 plus 11.2 divided by 2 times 4. Plugging it all in, you get 33. Oh, you can't even see it. 33.2 meters squared. There it is on 66. Yet again, we have one where you're not really clear which units to use. Yards and feet, it's multiply by 3 or divide by 3. So on this particular one, if you're going from 18 and you're trying to turn it into yards, so if you're trying to turn that into yards, you would do divide by 3. So if I were to divide by 3, that's going to give us 6 yards. And if I were to multiply this one by 3, it's times 3, and that's going to give us 18 feet. So turns out this is a square because it's the same lengths on both sides. So your area is going to be 6 squared, which is 36 yards squared there, or the area is going to be 18 squared, which is 324, I think. Why is my brain not working? Feet squared. I was right. It is 324. All right. We're almost to the end here. Question 67. Another easy one. Another diagonals. Here we go. 5.6 times 4 divided by 2. What's that going to be? It's going to be 11.2 yards squared. Don't even need a calculator on that one. We got 7.5 times 7.5. I'm not trusting my squares right now. I didn't trust it 5 seconds ago. Squared is going to be 56.25 miles squared. We're almost done. Question number 69. Nice. All right. Parallelogram, because you have 2 sides equal length there, has to be a parallelogram. If you have those 2 sides equal and they're connected, whatever. So anyways, parallelogram is base times height perpendicular, so 10.5 times 12. Really, it should have been 12 times 10.5, but you get the same result. And this one here, 63. You plug that into your calculator. I really hope I actually did make a single mistake on here, and someone can catch it, earn themselves an extra little candy. I'm just getting to the point where I'm a little bit, I don't know, a little bit done, you know, just kind of done. Anyways, you can't even see. You see how done I am? You can't even see what work I'm doing. I wonder if you can even see that previous one that I did with the 56.25. There's that one. You couldn't see it. All right, 39, 3.9 times 9. Super duper close. We have 35.1 kilometers squared. We're almost done, but now we're doing the same thing, but backwards. So on question 71, you're told that the area is 35.28. So 35.28 is going to be equal to the question mark. I'm going to go ahead and use the letter X instead of a question mark. X multiplied by 9.8, all that divided by 2. To solve this one, you have a couple choices. I think the most natural way is to try to get rid of fractions right away. So I'm going to multiply both sides by 2 and then divide by 9.8. But I won't plug any of that into my calculator until the very last step, because otherwise I'm just kind of wasting energy. And I'm not a fan of that waste. You could also simply do 9.8 divided by 2 to get 4.9 and then divide. You get the same answer either way. Regardless of what you do, you end up with 7.2. And this is back to regular inches because you're not asking about squared, so do be careful with that. Over here, exactly the same formula. Not sure why this formula is showing up so often, but 18 is going to be equal to that same letter x times 12 divided by 2. And on this one, I think we could actually just do it in our head, right? Well, I won't do it in my head, but we could. There we go, equals x. I'll do it in my head now. Because what I was saying, you do it in your head, 12 divided by 2 is 6, and then you divide both sides by 6, and you get 3. And it's just yards. All right, 2 more questions, guys. And we're finally done. I'm free. 25.9 is equal to 1/2 times the base times the height that is perpendicular to the base. I'm going to call it x. So I think the easiest way to do this is to do 2 times that 25.9 and then divided by 5.7 is equal to x. 2 times, I'm using my calculator by the way, divided by 5.7. We get a weird number here. It looks like we get 9.08. Oh, wait, 1 decimal place. 9.1. Here we go, 9.1 meters. Oh, that's what happens right at the end, guys. 9.1 meters. I'm really sorry. Making mistakes left and right. We have one more area question. That's a 1/2 base times height idea. So our 21.3 is going to be equal to 1/2 times that 8.5 times that letter x, 2 times 21.3 divided by 8.5 equal to x, or in other words, 2 times 21.3 divided by 8.5, and you get 5.0 miles. Finally done. Have a great rest of your day, guys, and peace out.